Welcome to SASE Vendor Terminology Comparison. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. In today's comprehensive presentation, we're going to dive deep into the world of Secure Service Edge, commonly known as SASE. This technology has become absolutely critical for modern enterprises as they navigate the complexities of securing distributed workforces and cloud-based applications. What makes this presentation unique is that we're going to compare the terminology used by 5 major SASE vendors: Palo Alto Networks Prisma Access, Fortinet FortiSASE, Cisco SASE, Zscaler, and Cato Networks. Each of these vendors has developed their own terminology and naming conventions, which can make it challenging for IT professionals to understand the equivalent components across different platforms. By the end of this presentation, you'll have a clear understanding of how each vendor approaches SASE, what their key components are called, and how their terminologies map to the core SASE capabilities defined by Gartner. This knowledge will be invaluable whether you're evaluating SASE solutions, studying for certifications, or simply trying to communicate more effectively with colleagues who use different platforms. SSE versus SASE, understanding the distinction. Before we proceed, it's crucial to understand the distinction between SSE and SASE, as this terminology appears frequently across all vendors. In 2021, Gartner recognized that some organizations might want to adopt cloud-delivered security without completely transforming their network infrastructure. This led to the definition of Secure Service Edge, or SSE, as a subset of SASE. SSE focuses purely on the security services component. It includes Secure Web Gateway, CASB, Zero Trust Network Access, and Firewall as a Service capabilities. Organizations can implement SSE when they want cloud-delivered security but aren't ready for or don't need the full SD-WAN component of SASE. SASE, on the other hand, includes everything in SSE plus the SD-WAN networking component. This provides the complete convergence of networking and security that Gartner originally envisioned. The diagram shows this relationship clearly. SSE sits as a subset within the larger SASE framework. The SSE portion contains Secure Web Gateway, CASB, Zero Trust Network Access, and Firewall as a Service. When you add SD-WAN to SSE, you get the complete SASE solution. Different vendors approach this distinction differently. Some, like Zscaler, started with SSE capabilities and added networking partnerships later. Others, like Cato Networks, built both networking and security together from the beginning. Understanding this distinction will help you navigate vendor solutions more effectively. Prisma Access Key Terminology. Now let's break down the specific terminology used in Prisma Access. Understanding these terms is essential for anyone working with or evaluating this platform. GlobalProtect is the endpoint agent that mobile users install on their devices. It supports Windows, Mac OS, iOS, Android, Chrome OS, and Linux. GlobalProtect tunnels user traffic to Prisma Access for policy enforcement and threat prevention. It also provides Host Information Profile, or HIP, reporting for device posture assessment. Mobile Users Service Plane Nodes, abbreviated as MU-SPN, are the cloud-based firewalls that Palo Alto manages specifically for mobile user connections. When your GlobalProtect client connects, it's connecting to these managed infrastructure components. Remote networks is the Prisma Access term for branch office connectivity. Branches connect via standard IPsec VPN tunnels using their existing SD-WAN edge devices, routers, or third-party firewalls. Service connections provide secure connectivity between Prisma Access and your data center or headquarters. This ensures that traffic destined for internal applications can be securely routed. ION stands for Instant On Network, and these are Prisma's SD-WAN appliances. They range from ION 1000 for small branches to ION 9200 for large data centers. ION devices are designed for zero-touch deployment and automatically establish tunnels back to Prisma access. ADEM stands for Autonomous Digital Experience Management. It's a monitoring service that provides segment-wise insights across the entire service delivery path, using both real and synthetic traffic analysis to identify and help remediate digital experience issues. Fortinet FortiSASE Overview. Now let's examine Fortinet's approach to SASE with FortiSASE. Fortinet has a unique position in the market because they've built their SASE solution on FortiOS, the same operating system that powers their FortiGate firewalls. This means organizations using FortiGate appliances will find a very familiar experience. FortiSASE is a cloud-delivered security service that implements the SASE architecture using Fortinet's Security Fabric. The Security Fabric is Fortinet's approach to integrated, automated security across the entire digital attack surface. The FortiSASE solution includes several key components. FWaaS functionality is based on FortiSASE next-generation firewall features. SWG functionality leverages FortiSASE explicit web proxy, captive portal, and authentication capabilities. FortiGuard Labs Threat Intelligence powers both FWaaS and SWG functions. Looking at the diagram, FortiSASE uses Global Security Points of Presence, or POPs, to provide access to remote users. Users can connect through agent-based, agentless, or site-based methods. The FortiSASE platform then provides secure access to the Internet, software as a service applications, and privately hosted applications in data centers. What distinguishes Fortinet's approach is their emphasis on integration with the broader Fortinet ecosystem. If you're already using FortiGate firewalls, FortiSwitch, or FortiAP access points, FortiSASE can integrate seamlessly with these existing investments. FortiSASE Additional Components. FortiSASE includes several additional components that integrate with the core platform. Understanding these will give you a complete picture of the Fortinet SASE ecosystem. FortiSASE is Fortinet's cloud-native cloud access security broker solution. It provides visibility, compliance, and data protection capabilities for cloud-based applications and services. FortiSASE operates as a software as a service offering and integrates with FortiSASE to extend security controls to cloud environments. FortiGuard Labs is Fortinet's threat intelligence and research organization. FortiGuard provides the threat intelligence feeds, security updates, and research that power FortiSASE's security capabilities. This includes antivirus signatures, intrusion prevention signatures, web filtering categories, and more. Inline CASB is a FortiSASE feature that enforces security policies in line with traffic used to access cloud applications. This differs from a PI-based CASB in that it inspects traffic in real time as users access cloud applications, rather than scanning cloud environments through a PIs. ThinEdge is a lightweight security solution designed for remote offices, small branches, and cloud environments. It provides basic security functions, secure connectivity, and traffic optimization, offering a cost-effective way to extend SASE capabilities to edge locations that don't need full-featured appliances. FortiGate secure SD-WAN appliances form the foundation for branch connectivity in Fortinet's SASE architecture. These appliances combine SD-WAN functionality with NGFW features, IPS, antivirus, and web filtering. They can connect to FortiSASE to extend cloud-delivered security to branch locations. FortiSASE Architecture Flow. Let's examine how traffic flows through the FortiSASE architecture. Understanding this flow will help you see how the various components work together. The architecture supports three main user types: agent-based users with FortiSASE Client installed, agentless users who access through web browsers or explicit proxy configuration, and site-based users at branch offices connected through FortiGate SD-WAN or IPsec tunnels. Looking at the sequence diagram, the flow begins when a remote user initiates a connection through FortiSASE. FortiClient connects to the FortiSASE cloud platform and sends user credentials for authentication. FortiSASE validates the user against the configured identity provider through SAML or other authentication methods. Once the user is authenticated, FortiSASE retrieves endpoint posture data from FortiClient EMS. This posture data includes information about the device's security status, including antivirus status, patch level, and compliance with security policies. Based on the user identity and device posture, FortiSASE applies the appropriate security policies. These policies determine what the user can access and what security inspections are applied to their traffic. When the user accesses the Internet, their traffic passes through the Secure Service Edge and Firewall as a service components for threat inspection and policy enforcement. When accessing private applications, Zero Trust Network Access validates access rights before establishing the connection. For software as a service application access, the CASB component applies visibility and control policies. Throughout the session, FortiSASE continuously monitors traffic, applies security policies, and logs activity for analytics and reporting purposes. Cisco SASE Overview. Now let's explore Cisco's approach to SASE. Cisco has a unique position in the market because their SASE solution is built from multiple established products that have been integrated together. This is different from vendors who built their SASE platforms from scratch. Cisco's SASE architecture combines several key product families. Cisco Umbrella serves as the core cloud security platform, providing DNS layer security, secure web gateway, cloud access security broker, and firewall as a service capabilities. Cisco Secure Access is their newer SSE solution that was made generally available in September 2023. For SD-WAN connectivity, Cisco offers two main options: Catalyst SD-WAN, formerly known as Viptela, and Meraki SD-WAN. Each platform has different strengths and is suited for different deployment scenarios. Cisco Duo provides identity and access management with multi-factor authentication and zero trust capabilities. ThousandEyes delivers digital experience monitoring to ensure optimal application performance across the entire service delivery path. The diagram illustrates how these components come together. Users and sites connect through various methods to the Cisco SASE cloud, which provides unified security and networking services. The key differentiator for Cisco is their breadth of integration options with existing enterprise infrastructure. Cisco SD-WAN options. Cisco offers two distinct SD-WAN platforms that integrate with their SASE architecture, each with different management approaches and target use cases. Catalyst SD-WAN, formerly known as Cisco Viptela, is a cloud-delivered overlay WAN architecture. It uses four primary components. vBond is the orchestrator that must be fully connected with every device for initial authentication. vSmart is the cloud-based controller that manages all data and control policies. vEdge routers get their configuration and routing information from vSmart. And vManage is the centralized management console for configuration and monitoring. Catalyst SD-WAN is typically deployed in larger enterprises that need sophisticated policy control, segmentation, and advanced routing capabilities. It supports a wide variety of Cisco routers and platforms. Meraki SD-WAN takes a different approach with cloud-managed simplicity. The Meraki MX appliances provide integrated security and SD-WAN functionality managed through the Meraki dashboard. This platform is designed for organizations that want simplified deployment and management without sacrificing functionality. Both SD-WAN platforms can integrate with Cisco Umbrella to route internet-bound traffic through the cloud security stack. They can also integrate with Cisco Secure Access for comprehensive SASE capabilities. The choice between Catalyst and Meraki often depends on existing Cisco infrastructure, IT team expertise, and the level of control versus simplicity desired. Cisco ThousandEyes Digital Experience Monitoring. ThousandEyes is Cisco's network intelligence and digital experience monitoring platform. In the context of SASE, ThousandEyes provides critical visibility into application performance across networks that the organization doesn't own or control. When organizations adopt SASE, they become more dependent on external networks, cloud services, and internet connectivity. Traditional monitoring tools can't see into these environments, creating blind spots that make troubleshooting difficult. ThousandEyes addresses this challenge. ThousandEyes deploys agents at various points throughout the network. Cloud agents are deployed by ThousandEyes across many locations globally and are immediately available for testing. Enterprise agents are deployed by customers in their own locations such as branch offices, data centers, and cloud environments. Endpoint agents run on user devices to monitor the experience from the user's perspective. These agents run synthetic tests to monitor domain name system resolution, browser response times, network path characteristics, routing status, and voice over IP quality. The data collected provides end-to-end visibility from the user to the application. In Cisco's SASE architecture, ThousandEyes integrates with secure access through Experience Insights. This provides detailed information on endpoint health, network stability, and software as a service application performance. When issues occur, ThousandEyes can pinpoint whether the problem is in the user's LAN network, the ISP, the SASE cloud, or the application itself. This capability is essential for reducing mean time to identify and mean time to resolve issues. It also provides data for effective escalations to service providers and helps eliminate finger pointing between internal teams and external vendors. Cisco SASE architecture flow. Let's examine how traffic flows through Cisco's SASE architecture to understand how all the components work together. The flow begins when a remote user attempts to access an application. The user's device has the necessary Cisco agents installed, including any Connect or Secure Access client, and potentially the ThousandEyes endpoint agent. First, the user's traffic is directed to Cisco Umbrella or Secure Access for security inspection. DNS queries are evaluated against Umbrella's threat intelligence to block known malicious domains before connections are established. For web traffic, the Secure Web Gateway inspects and filters content, applying corporate policies and scanning for threats. For cloud application access, CASB policies are applied to control shadow IT and protect data. When the user needs to access an internal application, Duo validates their identity through multi-factor authentication. Duo checks the user's credentials against the identity provider and sends a push notification or other second factor for verification. Once authenticated, if the application is accessed through Duo Network Gateway, the user connects without a traditional VPN. For VPN-based access, any connect establishes the secure tunnel. Throughout this process, ThousandEyes monitors the digital experience, collecting data on network performance, application response times, and any issues that might affect the user experience. The sequence diagram illustrates this flow, showing the interactions between the user, Cisco's security services, identity verification, and ultimately access to the application. Each step is monitored and logged for security analysis and compliance. Zscaler Internet Access-ZIA. Zscaler Internet Access, commonly referred to as ZIA, is the cloud security platform that protects users accessing the Internet and software as a service applications. It acts as a secure on-ramp to the Internet, inspecting all traffic inline. ZIA operates through what Zscaler calls public service edges, previously known as Zscaler Enforcement Nodes or ZENs. These are the cloud-based inspection points distributed across Zscaler's global network. When a user's traffic reaches a service edge, it's inspected and policies are enforced. The traffic forwarding to ZIA can happen in multiple ways. Enterprises can establish GRE or IPsec tunnels from their site routers to the nearest Zscaler data center. Mobile users forward traffic via the Zscaler Client Connector, which is the endpoint agent. Alternatively, traffic can be forwarded using PAC files for browser-based proxy configuration. ZIA's security capabilities include a cloud firewall that provides full Layer 7 inspection, a cloud intrusion prevention system, cloud sandbox for analyzing unknown files, Cloud DLP to prevent data loss, CASB for cloud application visibility and control, and browser isolation to protect against web-based threats. One of ZIA's key features is its ability to perform full TLS/secure sockets layer inspection at scale. Since approximately 95% of outbound traffic is encrypted, the ability to decrypt and inspect this traffic without performance degradation is critical. ZIA's cloud architecture provides the capacity to inspect all TLS/secure sockets layer traffic. ZIA also provides compliance reporting and can measure configurations against multiple frameworks with automated remediation capabilities. Zscaler Private Access-ZPA. Zscaler Private Access, or ZPA, provides zero-trust access to private applications. Unlike ZIA, which focuses on internet-bound traffic, ZPA secures access to internal applications whether they're in the data center or in the cloud. ZPA is fundamentally different from traditional VPN. With VPN, users are placed on the LAN and can potentially access any resource. With ZPA, users connect to specific applications only, never to the network itself. This inside-out architecture makes applications invisible to the Internet. The ZPA architecture includes several key components. The ZPA Central Authority manages authentication and authorization decisions. ZPA Public Service Edges are the cloud-based enforcement points. App connectors are lightweight software deployed in the same LAN segment as the applications being protected. These connectors establish outbound connections to Zscaler's cloud, meaning no inbound ports need to be opened. The Zscaler Client Connector on user devices works with both ZIA and ZPA. When accessing a private application, traffic is sent to the ZPA service edge where policies are evaluated. If access is permitted, the traffic is stitched through to the appropriate app connector, which then forwards it to the application. ZPA supports application segmentation, meaning you can define precisely which users can access which applications. Access policies can be based on user identity, device posture, location, and other contextual factors. It's important to note that ZPA only supports client-to-server communications. Other models like server-to-client or client-to-client are not supported. This reflects the zero-trust principle of minimal, specific access. Zscaler Key Terminology Deep Dive. Now let's explore the complete terminology used in Zscaler's platform. Understanding these terms is essential for anyone implementing or managing a Zscaler environment. The Zero Trust Exchange is the foundational concept in Zscaler's architecture. It's the cloud-native platform that brokers secure connections between users and applications. The key principle is that users connect to applications through Zscaler's cloud, never directly to the network. This eliminates the traditional attack surface associated with network-based access. Zscaler Client Connector, formerly known as Zscaler App, is the unified endpoint agent that works with both ZIA and ZPA. It's installed on user devices and intercepts traffic, forwarding it to the appropriate Zscaler service. When a user requests access to an internet resource, Client Connector sends traffic to ZIA. When accessing a private application, traffic goes to ZPA. The Central Authority is a critical component in the Zscaler architecture. It manages authentication, authorization, and policy decisions. When we looked at ZIA and ZPA architecture, the Central Authority is what validates users and determines what they can access. Public Service Edges are the cloud-based enforcement points distributed globally. For ZIA, these inspect internet-bound traffic. For ZPA, they broker connections to private applications. The term, Service Edge, replaced the older terminology of Zscaler Enforcement Nodes, or ZENs. Private secure service edges can be deployed within customer environments for scenarios requiring local traffic processing, such as compliance requirements or latency-sensitive applications. Zscaler Digital Experience, ZDX. Zscaler Digital Experience, or ZDX, is Zscaler's digital experience monitoring solution. It provides visibility into the end-to-end user experience when accessing applications through the Zscaler platform. ZDX monitors the entire path from the user's device through the network, across Zscaler's cloud, and to the destination application. This comprehensive visibility helps identify where performance issues originate, whether in the user's local environment, their ISP, Zscaler's infrastructure, or the application itself. The monitoring capabilities include device health metrics such as CPU utilization, memory usage, and network adapter status. Network performance is tracked including latency, packet loss, and jitter across each segment of the path. Application response times are measured to understand the actual user experience. ZDX uses both real user monitoring and synthetic probes. Real user monitoring captures actual traffic patterns and performance as users work. Synthetic probes actively test connectivity and performance to critical applications even when users aren't actively accessing them. One powerful feature of ZDX is its ability to provide segment-by-segment analysis. When a user reports slow application performance, ZDX can show whether the issue is in the user's Wi-Fi, their home network, the ISP, Zscaler's secure service edge, or the application's hosting environment. This dramatically reduces troubleshooting time. ZDX integrates with the Zscaler admin portal, providing dashboards and alerts that help IT teams proactively identify and resolve issues before they impact productivity. Cato Networks Negative Overview. Now let's turn our attention to Cato Networks, which has a unique position in the SASE market. Cato claims to have been delivering SASE capabilities since 2015, 4 years before Gartner coined the term. They built their platform as a converged, cloud-native service from the very beginning. Cato's approach centers on what they call the Cato SASE Cloud Platform. This is a globally distributed cloud service that provides both networking and security capabilities to all edges, including locations, cloud resources, and mobile users. The key differentiator for Cato is true convergence. Rather than integrating separate products, Cato built a single software stack that handles both networking and security functions. They process packets through what they call a single-pass cloud engine, inspecting traffic once for both network optimization and security rather than through multiple serial inspections. Cato's architecture consists of globally distributed points of presence, or POPs, that run on bare metal compute nodes within top-tier hosting facilities. These POPs are interconnected to form a global private backbone that provides optimized routing between locations. Looking at the diagram, you can see how Cato connects different types of edges. Physical locations connect via Cato Socket SD-WAN devices. Mobile users connect via the Cato Client. Cloud resources can connect through virtual sockets or cloud interconnect options. All traffic flows through the Cato SASE cloud where both networking and security services are applied. Cato has been recognized as a leader in Gartner's Magic Quadrant for SASE platforms, validating their approach to converged networking and security. Cato SSE 360. Cato SSE 360 is Cato's implementation of Secure Service Edge. The 360 in the name reflects Cato's claim that their SSE provides 360-degree visibility and control over all enterprise traffic, not just internet-bound traffic. Traditional Secure Service Edge solutions, as defined by Gartner, focus on three main capabilities: SWG, CASB, and ZTNA. However, Cato argues that this definition leaves blind spots. Traditional Secure Service Edge solutions inspect internet traffic and specific application access but don't have visibility into WAN traffic between sites. Cato Secure Service Edge 360 extends security to all traffic traversing the Cato network, including east-west WAN traffic between branch locations. This means threats like ransomware propagating across the WAN can be detected and stopped, which wouldn't be visible to a traditional Secure Service Edge solution. The components of Cato SSE 360 include Firewall as a service for network segmentation and Zero Trust policy enforcement. Secure Web Gateway provides web filtering and threat prevention. Intrusion Prevention System detects and blocks network-based attacks. Next-generation anti-malware provides file-based threat prevention. DNS Security protects against DNS-based threats. Remote Browser Isolation creates secure browsing sessions. CASB provides cloud application visibility and control. DLP prevents data loss. And ZTNA provides zero-trust access to applications. All of these capabilities are built into the SPACE architecture and applied uniformly to all traffic. This is different from competitors who may have separate engines for different security functions. Cato Client and Remote Access. The Cato Client is the endpoint agent that provides secure remote access for mobile users. It's available for Windows, Mac, iOS, Android, and Linux platforms. When the Cato Client connects, it establishes a secure, optimized connection to the Cato SASE cloud platform. From there, users can access any application whether it's on premises, in the cloud, or on the internet. All traffic is routed through Cato's security stack, ensuring consistent protection regardless of where the user is located. The Cato Client provides universal zero-trust network access capabilities. It enforces the organization's risk-based application access policies whether the user is in the office, on the road, or working from home. Before granting access, Cato ZTNA performs extensive device posture analysis and integrates with identity providers to ensure full authentication and compliance with corporate policies. An important recent addition is endpoint protection capabilities built into the Cato Client. The client now includes Endpoint Protection Platform, or EPP, and Endpoint Detection and Response, or EDR, functionality. A next-generation anti-malware engine detects malicious files, and the client correlates on-device suspicious activity for threat detection. The endpoint data collected by the Cato Client is sent to Cato's cloud-based data lake. Combined with network context from the SPACE engines, this enables Cato's XDR capabilities to create a comprehensive picture of security incidents across both endpoint and network domains. For third-party users or scenarios where installing an agent isn't possible, Cato offers clientless access through an application portal. This provides secure access to specific applications without requiring the full client installation. Cato Networks Complete Terminology Summary. Let's consolidate all the key Cato Networks terminology into a comprehensive reference. Cato SASE Cloud Platform is the overall name for Cato's converged networking and security service. It encompasses all components delivered as a cloud service. SPACE, the single-pass cloud engine, is the core processing architecture that handles both networking and security in a unified engine. Points of presence, or POPs, are the globally distributed data centers where SPACE instances run. Cato operates 75+ POPs worldwide. SSE 360 is Cato's secure service edge implementation that provides 360-degree visibility across all traffic types, not just internet-bound traffic. Cato Socket is the SD-WAN edge device for physical locations. vSocket is the virtual version for cloud deployments. Cato Client is the endpoint agent for remote users with built-in zero-trust network access and EPP/EDR capabilities. The Cato Management Application is the single pane of glass for all configuration, analytics, and troubleshooting. Cato XDR provides extended detection and response capabilities by correlating endpoint and network security events. Firewall as a service within Cato controls traffic flow across all ports and protocols in both WAN and Internet directions. The cloud network is Cato's global private backbone that interconnects all points of presence and provides optimized routing. Understanding these terms will help you effectively evaluate and work with Cato's SASE platform. Cross-vendor comparison endpoint agents. Now that we've covered each vendor's terminology individually, let's bring it all together with cross-vendor comparison tables. These comparisons will help you quickly translate terminology between platforms and understand the equivalent components across different SASE solutions. Let's start with endpoint agents, which are the software components installed on user devices to connect to the SASE platform. Every vendor has their own agent with different naming conventions. Palo Alto Networks uses GlobalProtect as their endpoint agent. GlobalProtect has been around for many years as part of their firewall ecosystem and provides VPN connectivity, HIP reporting for device posture, and integration with Prisma Access for SASE. They also have a newer Prisma Access agent that provides additional capabilities. Fortinet uses FortiClient as their endpoint agent. FortiClient provides VPN connectivity, ZTNA capabilities, and endpoint security features. It's managed centrally through FortiClient EMS. Cisco has multiple options depending on the deployment. AnyConnect is their traditional VPN client, while Cisco Secure Client is the newer unified agent that works with secure access. Duo also has its own authentication components. Zscaler uses the Zscaler Client Connector, formerly known as Zscaler App. This unified agent handles traffic forwarding for both ZIA and ZPA services. Cato Networks uses the Cato Client, which provides zero-trust network access connectivity along with built-in endpoint protection platform and endpoint detection and response capabilities for endpoint protection. Cross-vendor comparison SD-WAN components. SD-WAN is a critical component of SASE, providing the networking foundation that connects branch offices and data centers to the cloud security services. Each vendor approaches SD-WAN differently. Palo Alto Networks offers Prisma SD-WAN with their ION device family. The ION devices range from the ION 1000 for small branches up to the ION 9200 for large data centers. These devices are designed for zero-touch deployment and integrate natively with Prisma Access. Fortinet leverages their FortiGate appliances for SD-WAN functionality. FortiGate Secure SD-WAN combines SD-WAN with integrated next-generation firewall capabilities. This means the same device provides both networking and security functions at the branch. Cisco offers two distinct SD-WAN platforms. Catalyst SD-WAN, formerly Viptela, is their enterprise-grade solution with sophisticated policy controls through vManage, vSmart, vEdge, and vBond components. Meraki SD-WAN provides a simpler, cloud-managed approach using MX appliances managed through the Meraki dashboard. Zscaler does not offer their own SD-WAN devices. Instead, they partner with third-party SD-WAN vendors and provide the branch connector for simplified branch connectivity. Organizations using Zscaler need to obtain SD-WAN appliances from other vendors and integrate them with Zscaler's security services. Cato Networks offers the Cato Socket as their SD-WAN edge device. The socket provides full SD-WAN capabilities including link aggregation, quality of service, and dynamic path selection. For cloud deployments, they offer virtual sockets called vSockets. Cross-vendor comparison management platforms. Centralized management is essential for SASE deployments. Each vendor has developed their own management platform with different capabilities and approaches. Palo Alto Networks uses Strata Cloud Manager as their unified management platform for both Prisma Access and on-premises next-generation firewalls. This provides a single pane of glass for policy management, analytics, and operations. Organizations can also use Panorama for on-premises management scenarios. Fortinet provides multiple management options. FortiSASE has its own cloud-based management portal. FortiManager can be used for broader Fortinet infrastructure management. FortiClient EMS specifically manages endpoint agents and provides the endpoint management service functionality. Cisco's management is distributed across multiple platforms depending on the components in use. The Umbrella dashboard manages Umbrella security services. vManage manages Catalyst SD-WAN. The Meraki dashboard manages Meraki infrastructure. Duo Admin Panel manages identity and access. SecureX provides cross-product visibility and orchestration. Zscaler uses the Zscaler Admin Portal as their unified management interface. From here, Administrators can manage both ZIA and ZPA policies, configure access rules, and monitor the environment. The portal provides comprehensive analytics and reporting capabilities. Cato Networks emphasizes their single pane of glass approach with the Cato Management application. This single interface manages all networking and security capabilities, provides analytics and troubleshooting tools, and offers a unified API for automation and integration. Master Terminology Reference Part 1. Let's create a comprehensive master reference that maps common SASE concepts to each vendor's specific terminology. This reference will be invaluable when working across different platforms or evaluating solutions. For the overall SASE platform name, Palo Alto uses Prisma SASE, which combines Prisma Access and Prisma SD-WAN. Fortinet calls their solution FortiSASE. Cisco refers to their offering as Cisco SASE, built on umbrella and secure access with SD-WAN options. Zscaler uses Zero Trust Exchange as their platform name, and Cato calls theirs the Cato SASE Cloud Platform. For the Secure Service Edge component specifically, Prisma Access is Palo Alto's SSE. FortiSASE provides the SSE functions for Fortinet. Cisco Umbrella and Secure Access deliver SSE capabilities for Cisco. Zscaler Internet Access, or ZIA, is Zscaler's SSE offering. And Cato SSE 360 is how Cato refers to their security stack. The endpoint agent names are GlobalProtect for Palo Alto, FortiClient for Fortinet, Secure Client or AnyConnect for Cisco, Zscaler Client Connector for Zscaler, and Cato Client for Cato Networks. SD-WAN appliances are called ION devices in Prisma, FortiSASE SD-WAN for Fortinet, Catalyst or Meraki SD-WAN for Cisco, third-party or branch connector for Zscaler, and Cato Socket for Cato. ZTNA implementations are provided through GlobalProtect and Prisma Access Agent for Palo Alto, Secure Private Access for Fortinet, Duo Network Gateway for Cisco, ZPA for Zscaler, and Universal ZTNA in the Cato Client for Cato. Architectural approaches compared. Beyond terminology, it is important to understand the different architectural approaches each vendor takes. These architectural differences can significantly impact deployment, operations, and capabilities. Palo Alto Networks built Prisma SASE by extending their on-premises next-generation firewall technology to the cloud. This means organizations familiar with Palo Alto firewalls will find consistent policy models and management paradigms. The advantage is deep integration with existing Palo Alto infrastructure. The consideration is that it originated from an appliance-based architecture. Fortinet similarly extended their FortiOS platform to the cloud with FortiSASE. The strength here is tight integration with the broader Fortinet security fabric. Organizations with existing Fortinet investments can leverage that familiarity. FortiSASE essentially delivers cloud-hosted FortiGate capabilities. Cisco's approach combines multiple acquired and developed products into a SASE architecture. Umbrella provides cloud security, Duo provides identity, ThousandEyes provides monitoring, and Catalyst or Meraki provides SD-WAN. The strength is best-of-breed components. The consideration is integration complexity between different products. Zscaler built a cloud-native security platform from the ground up. They focus purely on security and partner for SD-WAN. The strength is a true cloud-native architecture designed for scale. The consideration is the need for third-party SD-WAN integration. Cato Networks built a converged platform from inception. Both networking and security run in a single software stack with the SPACE architecture. The strength is true convergence with single-pass processing. The consideration is that they're a newer player compared to established networking and security vendors. Conclusion and resources. We've covered a tremendous amount of ground in this presentation, comparing the terminology used by 5 major SASE vendors: Palo Alto Networks Prisma Access, Fortinet FortiSASE, Cisco SASE, Zscaler, and Cato Networks. You should now be able to identify equivalent components across different platforms. When someone mentions GlobalProtect, you'll know it's Palo Alto's endpoint agent, equivalent to FortiClient, Zscaler Client Connector, or Cato Client from other vendors. You understand the architectural differences between vendors. Some built cloud-native platforms from scratch, while others extended existing products to the cloud. Some provide fully converged solutions, while others integrate multiple components. You can translate between vendor-specific terminology when working in multi-vendor environments or evaluating solutions. This skill is invaluable for architects, engineers, and decision-makers working with SASE technologies. For further learning, I recommend exploring each vendor's official documentation and architecture guides. Hands-on experience through labs and proof-of-concept deployments will deepen your understanding of how these platforms actually operate. Keep in mind that SASE is a rapidly evolving space. Vendors continuously add new capabilities and may introduce new terminology. Stay current by following vendor announcements and industry analyst reports. Thank you for your attendance. Please consider subscribing to the channel and liking this video.